Fields and properties store data in a class. Think of them as nouns. They tell us more about the class. Both are very similar, but they also have certain differences, some of which I will discuss shortly. Hi, I'm Victor, and today in Height Above Sea Level, we'll be looking at fields and properties in C#. Before we get started, if you want to talk more about this kind of thing, be sure to follow me on Twitch at Height Above Sea Level, where I do some live coding sessions as well as try and answer some of your questions as best I can. This video builds off of what we covered in the classes and access modifiers videos, so if you're not familiar with those topics, watch those videos first and I'll link them to the top right of your screen. Alright, fields and properties. A field, why don't we start with a field? A field is any variable declared directly inside a class, and it is typically recommended that any field be declared private or protected. Like we saw here in the previous access modifiers video, we declared this field called metal used and we set it to be private. Remember, if you don't set an access modifier, it's inferred that it's private, but for this instance, we will keep it as, we'll declare put the private keyword. And this is because we want to hide implementation detail. And this is because of a term known as encapsulation. This is just a brief recap of everything we covered in the previous video, just to bring anyone up to speed to where we are right now. So a field, any variable declared inside a class. So how do we declare it? Let's declare another one. We've seen this one. So why don't we declare another one? Let's say private float. We can say average. I can spell average speed. And this is the convention that you'll see a lot of people using. Some people don't use it, some do. When naming a field, you put an underscore and then camel case notation. So the first letter of the first word is lowercase. And then from there on, the first letter of each word is uppercase. So that is how you declare a field in C#, and it's a variable declared inside class. Normally, but let's say you wanted to be able to access a field. That's where properties would come in. If you wanted to access a field, you'd use a property along with the private backing field, but that is in the property section, which I will cover shortly. All right. But why would you ever need to declare a field? Why not just use a property? Because let's say you wanted to use this average speed. Right now we have three methods here. Let's say we wanted to use the average speed in all these three methods. Maybe I can call this method acceleration. Acceleration. If we didn't have this, then we need to create a variable called speed in here. Maybe set it to whatever speed you want the car to start at. And maybe you'll have to create another one in here, var another speed. Again, set that to 10. And then you have to create another one, var other speed. Set that to 10. You see, we're doing a lot of things, creating a lot of variables. And these are all different. I know I've set them equal to 10, but these variables are all different and they're only available inside these methods. And that's because of something known as scope. And I said I'd cover this, and I still believe I'll cover it in the methods video. So if you want to learn more about scope, consider subscribing and we will look at it in the methods video, God willing. But the thing about this speed variable, it's only available in here. And this one, even though it's set equal to 10, is different from this one and it's different from this one. But let's say you wanted to have a consistent value that we can use inside all these. We don't have to create it and it stays the same throughout. That's where a field comes in. And as you can see, it's private, so we can access it inside here, anywhere inside here. That's why we use a field. So we can say now for this variable, you can say speed is equals to, average speed is equals to, now this speed variable is equals to average speed multiplied, let's say we multiplied by 12. And then over here, average, we can even use it here as well. Average speed equals minus 10, whatever you want to do. You see, this average speed is going to be the same in all these methods, even here, if you want to use it here. That's why we have a field. It's a variable, remember, a variable declared directly inside a class. At its core, it's a variable, and we use it here. It's now available inside this class. So that is a field, but I said it's a variable. So just like these variables here, let's say you create this, and then you create this. A variable can be set equals to a value. Same thing for a field. We can set the field here to be average speed to be, let's say, 40 miles per hour. This is initializing the field. This is one place you can initialize a field. And even then, if you did something like this, average speed multiplied by 10, it's going to be this 40 multiplied by 10. We have initialized this field. If you leave it like this, remember it's going to be 0 because default value for numbers is 0. But you can initialize it here. And that is how, or that is why a field is used in classes. That's one of the reasons a field is used in classes. Another thing to note is that a field can be declared as read only. So what does that mean? That means you can't declare the value. So let's remove this read only value. You can do this. Remember, it's not declared. It's declared, but it isn't assigned a value. So you can say in here, you can say speed, average speed is equals to 100. You can even come in here and say average speed is equals to 45. So you see, we're assigning a value to this speed because it's not assigned a value. It's not assigned a value here, but it's assigned a value here. However, if I say this is read only, I can't assign a value to it. See, it's giving me an error because it's read only. You can only read the value. You can't access the value. That means that the only way you can give this field a value is if you initialize it up here, maybe 45, or inside the constructor. You can say average speed is equals to 25 or something like that. But just like these other properties, you can also say float speed. Maybe I'll remove these so that because we don't need them anymore. We can say average speed is equals to speed. And this is something you'll see happening a lot as you progress and write more code and look at other people's code. You'll see some more of this. So this average speed is going to be initialized in the constructor. These are the only two places you can initialize a field if you declare it as read only. So that right there is a little bit of an introduction to fields. And remember, because they're private, you can't access them out here. But if you want, you can put it to be public, such that if you create a, let's say we create a new car, Mitsubishi, new car, and then you can write on the console Mitsubishi dot underscore average speed. You see, we can access it if you want. Maybe I can say this is 100, and we remove this initialization because we are initializing it here. Control and F5. 100, because we set the speed equals to this. But one thing before I finish up on fields is what happens if you initialize it here and you initialize it in the constructor. Fields are initialized first here, but then the constructor comes in second. It overrides anything inside here, overrides if you initialize it like this. So this is going to be equals to this 100 that we pass. Remember that? The 100 that we pass becomes the average speed, and it overrides what you did over here. So Control and F5, 100. And that right there is fields in a nutshell. But again, remember, keep them private. You can make them read only. And these are implementation detail. All right. Real quick, if you're enjoying the content, please consider supporting me on patreon.com/height-above-sea-level. And all patrons will get this custom Sakura theme, a Visual Studio, as a thank you for their support. And I'll give you all the instructions of how to set it up, all the colors and everything to get your Visual Studio editor looking just like mine. So if you're enjoying the content, go over to patreon.com/heights-above-sea-level. And if you do support, you'll get this Sakura theme as a thank you. All right, why don't we look at properties? So far, we've been looking at these properties from the previous video, and these are called, and from the classes video and the access modifiers video, and these are called auto implemented properties. And what properties do is that they provide a way to interact with fields. Even though you don't see a field here, one is created behind the scenes. It's called a private backing field. But properties allow us to interact with fields, whether reading the value, setting the value, or doing some calculation, some computation. And that's where the properties come in. So right now, this is an auto-implemented property, but let's say we wanted to use a private field with a property, and this private field then becomes a backing field. So let me write that. If you're using this with a property, it becomes a backing field. So where's the property? Let's create it. We can say public string. We'll call this alloy. All right. And now in the get method, you remember getters and setters? Getters allow us to get the value of this metal used. We can say return metal used. So what it's simply saying is that whatever value this metal used has been declared as, when we access this using dot notation, it gives us that value. So we can even say this is equals to steel. So why don't we look at the alloy and the console? So here we have Mitsubishi, and we can say dot alloy. Remember, we're using the get method. When you do this dot notation, we're getting it. We want to get the alloy value. So when we get the alloy value, it returns to us the metal used value, which is equals to steel. If I press Ctrl and F5, steel. It's giving us this value. Remember, this is private. We don't have a way to access it. That's where we used a property so that we can access this. But doesn't that beat the purpose of setting it as private? Not exactly, because this is still implementation detail. You want to hide it, but these getters and setters, it's like this is inside a building and this is a window. When we have a getter, we now have a window to see what's inside the building, and this is for us who are making the program. We want to be able to see what's inside, and that's where we use the getter. But what about setting it? It's equal to steel. Now what if we wanted to set it? We use a setter, and this setter, we say, even there's a suggestion, we say metal used is equals to value. I press tab twice there to use the auto completion. So what does this mean? Let me remove this. All right, I see a little bit of an error. The get or set access are expected. What does that mean? Is that giving me an error? Let me press Ctrl and F5. That's fine. Oh yeah, it wasn't an error. It was just Visual Studio can be a bit slow sometimes. And then you'll see that error, but you can just give it a bit of time, a few seconds, and it'll be just fine. So what does this setter do? We're setting the value of metal used. So this keyword value is what we'll pass as the alloy. Let's say right now the alloy is steel. I press Ctrl and F5 because here it is. The metal used variable or field is initialized as steel. But if we want to change it, we will say Mitsubishi.alloy is equals to, let's say, tungsten. So this here, this value, this tungsten is what is this value. So that means we're setting this metal used here to this value that we provide here. All right. And if I press Ctrl and F5, tungsten. Ignore this little error that came at the end because again, Visual Studio can be a bit slow and that's why you see that error, but that is what's going to happen. You see tungsten because we set it equals to this metal used private field. All right. So let's look at another example real quick. This is a Let me move this up here so that we can see it better. This is the backing field, and this is a property that works with the backing field. So this property interacts with this field. So why don't we look at another one that does some computation? So this is the average speed. Let's say we wanted to use this max speed property to access this average speed variable. So first I'll need to change this so that it's a float as well. And then for the getters and setters, I can remove that. And then we do this. We do this. And now for the get, we want to do some work. All right. So 45, remember F, it's a float, so it has to have an F at the end. If this is a bit confusing, I have a video on numbers that I will link to the top right of your screen you should watch to get you up to speed on numbers in C#. But if you are, let's continue. So this max speed property interacts with this private field because this is the private backing field. Now when we're getting the value, well, let's say you wanted to do some work. So when we're getting the value, we want to say, return to me average speed multiplied by 2.5 F. So maybe I can put the average speed to be something simple like 10. All right. So what does that mean? Whenever we call the max speed, it takes the average speed that we have and multiplies it by 2.5 to give us the max speed. You know, why don't we write that on the console? So Mitsubishi dot max speed, control and F5, 250. And where are we getting that 250 from? Because when we access this like this, we're getting the value of max speed from Mitsubishi class, which is an instance of the car class. We're returning average speed multiplied by 2.5. So average speed is 10. Multiply that by 2.5. That gives us 250. Is it 10? Let me see if I'm getting this right. No, it's doing something else. It's doing something else that's, oh yes, here we are. Remember? I'm initializing this in the constructor. Okay, I see what's happening here. Remember, we initialized the average speed here, but because we have the constructor, this value overrides this average speed, and we set that over here. So it's multiplying this 100 times 2.5, and that's giving us 250. If I made it so that you didn't have to do this, and I removed this constructor, Control K, Control C, it should give us 25, because now we're using this value. Let's use this value like this, just so it's clear. You see, when you're getting it this way, using a property this way, it means that we're doing some work in between. We can do some work in between when we're getting the value. Same thing for setting. Let's say when we're setting the average speed, when we want to get to set this average speed, whatever value you give us, first we'll check if value, remember the value is whatever is on the right side of the equal sign, is less than 0. You'll write on the console, that value is too low. That value is too low. But let's say it's not. Remember if and else statements. Again, this is also part of the conditional statements video. I'll be linked to the top right of your screen if you're a bit confused on these. So if the value is less than 0, we write on the console, but if it isn't, let's say value, now we say average speed is now equals the value divided by 2.5. Or maybe you can say, keep this at like 40. So when we're setting the value, first we'll check, is it less than 40? If it is, you write the value is too low. If it's not, average speed is equals to the value divided, whatever you provide, divided by 2.5 F. So Mitsubishi dot max speed is equals to 100. When we set this 100, what we're doing is we're setting the value of average speed. We're not setting the value of this. We're setting the value of average speed. So that now when we get the value this way, it's going to look at the average speed, which is now 100, multiply that by 2.5, and then give it to us. So Control and F5, let's see, we just do 50. Oh, no. Sorry. Value divided by 2.5f. That's average speed. Oh, yeah. Sorry. So let's say we removed this. Now this is going to give us 250. Or 40. No, yeah, 40. I'm so confused. 100 divided by 2.5 is 40. 100 divided by 2, 50. Okay, it's making sense now. I was a bit confused there. But you see, we've set the max speed to 100. What does that do? It sets the average speed, this one, to that 100 divided by 2.5. So when we get the average speed, Control and F5, this one here. When we get the max speed, when you call max speed, it gets this method. It calls this getter. When you access it like this, then Control and F5, that should be the 40, because that value that you give us, this one, we divide it by 2.5. And if it's less than 40, let's say if you set this to 30, Control and F5, that value is too low. See that? That right there is properties in a nutshell. But what about before I finish, let me wind up real quick. What about auto-implemented properties? Well, auto-implemented properties do this exact same thing. Not minus the calculations. So let me just write it the full way. As you see this alloy, let me bring it down here so you can compare it. This is a long way. This is just a long version of this. Where the getter, if the getter just returns the value that you assign this alloy and the setter just assigns this value to the private backing field, this is the shorter way of writing it. And when you create an auto-implemented property, a private anonymous backing field is created automatically. So when you use a auto-implemented property, it's like there's a private field over here being created for you, like private string underscore color. So this is what happens in the background. This is created for you when you use this. So a private field is created on your behalf. And then this is the getter and the setter are written like this. That's what an auto-implemented property does. It just saves you from writing all this code, because it's inferred that the getter just gets the value and the setter just sets the private backing field to the value you specified. And one more thing before I finish is that you can use access modifiers in here. I mentioned this in the access modifiers video, but you can also use them for the getters and the setters. You can use private, protected, and internal, etc. So let's look at an example of this. So model name. Let's say Mitsubishi dot model name is equals to, let's just call it Mitsubishi. All right, and then we can access it this way. Dot model name. Put my semicolon at the end, and Control and F5. It's gonna write Mitsubishi Mark X, just so it's clear. Mark X. There you go. But what if we say that it's a private set? Remember, private can only be used, anything declared as private means it can only be used inside the class. And you see, now we get an error. Let me write Control and F5. The error is a bit slow to come, but there's an error here. That's why this is white. If it wasn't an error, then it would be this light blue. And even when I try to do Control and F5, you see there were build errors because you said that the setter is private. It can only be set, the model name can only be set in here. But if I remove this, error is gone. If I press Control and F5, everything is working. And if it's the same thing for here, I declare this as private, I'm going to get an error when I try to do Control and F5. There were build errors because I'm trying to access it over here, and it's a private get. That means it can only be accessed inside this class. And that right there is fields and properties in a nutshell. That's all I have for you guys. Did you learn something new today? Did you enjoy the video? And was I going too fast? Was I going too slow? And have you found fields and properties a little bit easier to understand now that you've made it this far? Let me know in the comments below. Again, if you did enjoy the content, please consider supporting me over on Patreon at patreon.com/heightabove-sea-level, and all Patreons will get this custom Sakura theme that I came up with. Also, I do stream on Twitch, so if you want to talk about this kind of thing live on stream, then follow me there. But if that doesn't work, come hang out in Discord instead. Just click the link in the description below and become a member of the Watcher Tribe today. Thank you so much for watching, and as always, from me to you, deuces.